Hello and welcome to my channel. It's your usual host, Mr. Miracle. We started with integration in our last video, so these are just more examples to handle. From the first question here, we have integral the root or the square root of x dx. So how do we do this? Also remember that the square root sign is also this according to the law of indices. So if we get this dx, then it is easier for us to integrate. So this should give us x raised to the power of half plus 1 all over half plus 1 plus c. So this should give us, this is a fraction plus a whole number, so 2 is the LCM here, so this is power of 2. 2 divided by 2 is 1, 1 times 1 is 1, plus 2 divided by 1, there's an invincible 1 here, is 2, 2 times 1 is 2. Same thing happens here, we have 1 plus 2 over 2 plus c. So this should give us x raised to the power of 3 all over, x raised to the power of 3 over 2 all over 3 over 2 plus c. Now we can resolve this by saying this alone is of itself, that is x raised to the power of 3 over 2 is dividing 3 over 2 plus c. So according to law of indices, it's called the reciprocal law for change of sign, that is between division and multiplication. So if we change this to multiplication, this is going to be x power 3 over 2 times 2 over 3. So it reciprocated plus c. So this should give us, this comes behind now since it's multiplying rather, so this is going to be 2 over 3 x raised to the power of 3 over 2 plus c, and this is our answer. Straightforward and simple. Now question 2, let's say solution 2. We have the integral 1 over the cube roots of x power 2 dx. We are going to follow the same way we solve this. Okay, so this is going to be integral 1 over x raised to the power of 2 over 3. Because this is the cube root. If it were to be the cube root of x only, that is this should give us x raised to the power of 1 over 3. So if we are taking out x raised to the power of 1 over 3, there's already 2 as the square there. So 2 multiplies this to come as the numerator. So this is where we are, the x. So we can further exemplify this to x minus 2 over 3. Yes, because of this 1. We moved everything to looking linear and no longer a fraction. So these are all laws of indices. So at this point we can integrate. So this should give us x raised to the power of minus 2 over 3 plus 1 all over minus 2 over 3 plus 1 plus c. So this is going to give us x raised to the power of 3 is the LCM there. 3 divided by 3 is 1 times 2, we have 2. There's a minus here. Plus 3 divided by 1, the invisible 1 we talked about, is 3 times 1 is still 3. So the same thing is applicable here. So we have minus 2 plus 3 all over 3 plus c. Okay, at this point, this is now minus 2 plus 3, which is 1. So we have that x is raised to the power of 1 over 3 all over, same thing happens here, minus 2 plus 3 is 1. So we have 1 over 3 plus c. We can resolve this fraction the same way we did here. So this is going to be x raised to the power of 3, 1 over 3 divided by 1 over 3 plus c. So this should be equal to x raised to the power of 1 over 3 times 3 over 1 plus c. This is equal to x, or we take this 3 behind, since everything is divided by 1 is still the same thing. So we have 3x raised to the power of 1 over 3 plus c, and this is our answer. Very simple. Okay, let's solve question 3. Now, to solve question 3, normally you knew or you have been taught in algebra expansion. It's called an algebraic expansion. So that's what we are going to do here. So we just say, this is now 3. We say the integral of x minus 1 into x plus 2 dx. I think we should resolve this outside before plugging it in. So we just expand this and bring it in. So this is x minus 1 into x plus 2. In expanding this, we can use one bracket to expand the other. So this should be x into x plus 2. We are using this minus 1, this one, into x plus 2. So if we expand this, this is going to give us x squared, that's x times x, plus x times 2 is 2x, minus 1 times x is x, minus 1 times 2 is minus 2. So this is 2x, this is 1x. Their coefficients here is 1 and 2. The variables are the same, so they are like terms. Since they are like terms, this is 2 minus 1. So this gives us x squared plus x alone minus 2. So this integral is now, okay, since you got this, let's clean it. Or, okay, let me just write. This should be equal to integral x squared plus x minus 2 dx. So since we also know that integration is commutative and also distributive, this can go through. So this becomes the integral of x squared dx plus the integral of x dx plus the integral, this minus, so it's minus here, of 2 dx. So we do their individual integration. So this is going to be, the first one is going to be x squared plus 1 over 2 plus 1 plus, this one is x, is going to give us x1 power 1 all over 1 plus 1 plus, this is a constant, it's going to give us, or it's minus, it's going to give us 2x then plus c. So if we resolve this, this is going to give us x cubed over 3 plus x squared over 2 minus 2x plus c. And this is the answer. So finally, for question number 4, we have integral of x plus 1 over x dx. So this should be equal to, since it is distributive, the integral of x dx plus the integral of 1 over x dx. So this should give us, the integral of x is x power 1 plus 1 all over 1 plus 1 plus the integral of a reciprocal function, as we did in our class earlier or in the previous class, is going to give us a lim, that is the natural log. So in this case, this is going to give us lim, the absolute value of x plus c. So this is going to be x power 2 over 2 plus the lim of the absolute value of x plus c. And this is our answer. So I believe it's simple enough to understand, and you can drop your comments on the comment section in case you have any question bothering you concerning this subject, this topic. And feel free to share the video as well. Subscribe so that you'll be notified on every upload. Just update yourself with mathematics and equip yourself probably for exams and other stuff that concerns math and your schooling. Thanks for watching. See you in my next video.